Okay, now that we have seen the 5 formulas that we're going to use, let's use those to tackle these 5 practice problems. Here's number 1. Find the concentration of HCl that has a pH of 2.5. I'm going to start every one of these problems the same way, and that's by writing an equation to show what happens when the chemical that's in the problem dissolves in water. So when HCl is put into water, the water is going to move in and rip apart the hydrogen and chloride and give us hydrogen ion and chloride ion. Now, it hasn't turned into something different chemically. The hydrogen and chloride have just separated from each other, and that's an important distinction and the reason why I haven't made the hydrogen and the chlorides diatomic. Okay, now what we're looking for is the concentration, so the molarity of the HCl, so that it will make a solution with a pH equal to 2.5. So if you take a look at the formulas that you wrote down, one of them is that the concentration of the hydrogen ion is equal to 10 raised to the negative pH power. So I'm going to take 10 and I'm going to raise it to the negative pH power. So on your calculator, you can perform this by hitting the second button and then the log button, and that's going to give you 10 with a caret, and then you can type in negative 2.5. When you do that and then hit equals, you're going to get 0.0032 molar. So that is really the concentration of the hydrogen ion. But this is important to note. Because we have the same coefficient in front of HCl and hydrogen, their concentrations are going to match. So whatever the concentration of hydrogen ion is, which again is this number, that would also be the concentration of the HCl. So this is the answer to the question. All right, let's go on and do number 2. Find the pH of a 0.18 molar H2SO4 solution. So again, step 1 is always going to be to write an equation to show what's happening when this solute, H2SO4, is dissolved in water. So again, the ions are going to separate from one another here, and we're going to end up with hydrogen ions. Remember that Arrhenius definition that tells us an acid is something that increases the concentration of hydrogen ion in water. Okay, now, if you take a look, you should notice this 2 here. So I'm going to put a 2 here, and what that shows is every time I dissolve one of these in water, I get 2 hydrogen ions and a sulfate ion. Okay, now let's take a look at what the question tells us. We have a concentration of our solute of 0.18 molar. Okay, so now we have to do a little bit of stoichiometry. Remember about the coefficients. So this time we have a 1 in front of H2SO4 and we have a 2 in front of a hydrogen ion. So that means that the concentration of the hydrogen ion is going to be double, or 0.36 molar, the concentration of the H2SO4. Now the question's asking us to find the pH. So pH is going to be equal to the negative log of the hydrogen ion concentration. So we're going to take the negative log of 0.36. So on your calculator, you're going to type negative and then hit the log button and then type in 0.36. And when you do that, you're going to get 0.44. And that is the answer to our question. Okay. Now the next 2 we're going to do are going to be problems involving bases. And you can tell that when you look at these formulas because instead of starting with H something, you should notice that these are going to end with OH, right? So that tells us that this is an Arrhenius base instead. And so when we write these equations, they're going to look a little bit different. And when we go to solve these, we're going to have an extra step. So let's start again by writing that formula. So find the pH of a 0.34 molar solution of NaOH. So we're going to write an equation to show what happens when we put sodium hydroxide in water. So it's going to separate into the ions that make it up, sodium and hydroxide. And we're given the concentration of the sodium hydroxide. So it is 0.34 molar. So every sodium hydroxide that you put in there breaks apart into sodium and hydroxide. So the concentration of the hydroxide is going to be the same, 0.34 molar. Now, when we solve these kinds of problems, someone almost always asks, well, what about the concentration of the sodium? What would that be? So what do you think? What would that be? You're right, that would be 0.342. And the reason that I'm not writing it down here is because, well, no one really cares. The thing is, what we're looking for is the pH, which is about hydrogen and hydroxide. We're not looking for the pNa. So sodium is involved here because it gives us hydroxide, but it's not the star of the show. So I'm not going to write its concentration down because it doesn't really matter in this problem. Okay, so now what you should notice is that what we have is the hydroxide ion concentration. So we have that formula, pH equals negative log of the hydrogen ion concentration, but we don't have that here. But we do know that pOH is equal to the negative log of the hydroxide ion concentration. So we can take the negative log of 0.34, and when we do that, we're going to get 0.47. Now that's the pOH. I wrote this formula down a second ago, but it turns out that we don't really need it. So let's erase it and replace it with pH plus pOH equals 14. So that's another of the relationships that we have. So we don't know the pH, but we do know the pOH now is 0.47. And when we add those two together, we should get 14, which means that our pH is equal to 13.53. So that's our answer. And just as a double check, remember we started by saying we know this problem is about a base because the formula ends with OH, and so we would want to make sure that its pH is higher than 14, and it is here. Okay, next one is a little bit more complicated. Find the hydroxide ion concentration and the pH of a 0.11 molar solution of strontium hydroxide. So again, we know this one is a base and not an acid because it ends with OH. So let's write that formula. Strontium hydroxide, when dissolved in water, is going to form strontium ions and hydroxide ions. And notice that I've put a 2 here because of this 2 here. So when we break our acids apart, we're always going to have hydrogen and an anion. And when we break our bases apart, we're always going to have a metal and the hydroxide ion. And then we'll have a coefficient out in front of the hydroxide ion to show how many hydroxides were in that formula. So the problem tells us that this is a 0.11 molar solution of strontium hydroxide, and we have to find the hydroxide ion concentration and the pH. Well, the hydroxide ion concentration is what we're going to write down right here. So again, notice we have a coefficient of 1 in front of the strontium hydroxide and 2 in front of the hydroxide, which means every time one strontium hydroxide like let's say formula unit comes apart, it's going to make 0.22 molar, twice as many hydroxide ions. So this is the first answer we were looking for. Find the hydroxide ion concentration. And now we need the pH of the solution. So remember, this is a base. So we can take the negative log of that concentration. And when we do, we'll have the pOH. So negative log of 0.22. And when we do that, we get 0.66. And then we know that pH plus pOH equals 14. So we can do pH plus 0.66 equals 14. And then pH equals 13.34. Okay, now we're going to put this all together with some things that we've learned earlier this year. So we have a solution of hydrochloric acid that has a pH of 1.6. and we want to know what's the mass of HCl that we would have to dissolve into 2.6 liters of solution in order to make that hydrochloric acid solution. So we'll start by writing our equation. When we put HCl into water, we get hydrogen ions and chloride ions. And we know that our solution has a pH of 1.6. So we have a formula that hydrogen ion concentration is equal to 10 to the minus pH power. So if we take 10 and raise it to the negative 1.6 power, we will get the hydrogen ion concentration, which is 0.025 molar. All right, back over here at our equation, that would be this value. It's the hydrogen ion concentration. Okay, notice that the stoichiometry here shows us we have a 1 in front of the hydrogen ion and a 1 in front of the HCl, which means whatever the concentration of the hydrogen ion is, that is also the concentration of the solute here, which is HCl. Okay, what we're looking for though is the mass of this stuff that we would have to put in order to make a solution that has a pH of 1.6 when we have 2.6 liters of solution. So I'm going to remind you what you learned in Unit 6, that molarity is equal to moles divided by liters. So we have a molarity, 0.025 molar, and we know that we have 2.6 liters of solution, and we don't know these moles, but we can solve algebraically, and when we do that, we're going to get 0.065 moles. We're almost done. Now the question is asking what's the mass of HCl, and we have moles. So one last step would be to convert. So we have moles below and grams above, 1 mole on the bottom, and on top the molar mass of hydrochloric acid, which we get by adding up the mass of hydrogen and chlorine off the periodic table. And of course these cancel, leaving us with grams, which is what we want, and we get 2.38 grams. Okay, it's time to practice on your own. Check out your homework questions.